Hey guys, welcome back to General Chemistry. Today we're going to continue our series of reactions that you're responsible for knowing, and today we're going to talk about acid-base reactions. So just as a reminder, we're working our way through this list. These are 4 common types of chemical reactions where I could give you the reactants and you'd be responsible for knowing what the products are and then writing a balanced equation. We talked about precipitation in our last lectures. Now we're going to talk about acid-base. So before we can dive into an acid-base chemical reaction, we first need to know what an acid and what a base are. Please know that this is a very quick explanation. For this class, I will help you out with what an acid and what a base is. But when you get to chemistry 2, we will talk much more detail about what an acid and a base are and how you can quickly identify them. But for now, I will tell you what the acid and what the base is, but let's at least be introduced to them. Oops. All right, so for an acid and a base, we're going to define an acid and define a base with respect to water. So what happens when I put an acid into water? What happens when I put a base into water? When I put an acid into water, it's going to be known for producing these hydrogen ions. So just like we talked about, ionic compounds dissociate. When we put them into water, they break apart into their ions. Well, acids are going to do the same thing. And the ion one of the ions that they're going to produce is that hydrogen ion. So our poster child for acids is hydrochloric acid, HCl. And so when I put HCl into solution, let me do it over here. It's going to break apart into 2 ions. It's going to break apart into chlorine ions, and it's going to break apart into hydrogen ions. And the presence of this hydrogen ion is what defines it as an acid. Just kind of a helpful hint, like I said, I'll help you with identifying acids and bases, but just a helpful hint, very often acids will begin with the letter H. So HCl would be an example, HNO3 would be an example. So very often they lead off with that hydrogen. For our bases, ignore this. For our bases, again, we're going to put them into water. They are going to dissociate or break apart into their ions, and bases are known for producing hydroxide ions at OH-. So the poster child for our base is sodium hydroxide. So when I put sodium hydroxide into solution, it's going to break apart into sodium ions, and it's going to break apart into hydroxide ions. And the presence of this hydroxide is what makes that a base. All right, so here's just some common strong acids. Like I said, you're not going to need to know these. You're not going to have them memorized, but at least you can look at kind of that theme that I was talking about where all of them start with this hydrogen, and so that'll just help you getting to know them. All right, so for an acid-base reaction, often called a neutralization reaction, here's the blueprint for that acid-base reaction. Of course, we are going to have an acid that reacts with a base. So that's always going to be there. When an acid and a base react with one another, they are always going to produce water. Water will always be one of the products. And then the other product will be a salt. Let me be very clear about the definition of a salt. A salt is actually just an ionic compound that dissolves in water. Okay, so when I say salt, automatically students are going to picture sodium chloride. Sodium chloride, of course, is an example of a salt, but it is not the only salt that exists. There are others that exist. So a salt is just going to be an ionic compound that dissolves in water. So this is your blueprint. Let's talk about how we got these different pieces. So if we look at our acid and our base, acids are going to take, acids are going to take this hydrogen in the front here, and that's going to be the hydrogen that they kind of give up or donate to the process of making water. And our bases are going to take their hydroxide, this OH, and that's going to be what they donate in the process of making water. Okay, so I have a hydrogen from from my acid. I have an OH from my base, and that is our water, H2O. Okay? So that's how we determine, or that's how we figure that the water is being made. How do we know what ionic compound is going to come out on the other side? Well, we just look at what is left. So when we take away that hydrogen, what is left for the first part is that chlorine. Okay. And if we take away the hydroxide, what is left from our base? It's the sodium. So that's how we determine what our salt is going to be, is just what are the ionic compounds that are left and how do they come together to form a molecule. The one thing that we have to be very careful of here is that we are writing an ionic compound onto the paper. So we do have to make sure that it is electrically neutral, balance those charges. And then from there, we'd have to balance the chemical equation. Okay. So let's look at an example that is not salt as the product. Let's look at this one. So first and foremost, this is words. So that naming compound stuff is not going to go away. You are going to need to be able to write compounds down if I write their name in words. Okay. So the base, that's how you know it's the base, magnesium hydroxide, reacts with hydrochloric acid. Write a balanced neutralization reaction. Okay. So first, let's get our reactants on the board. I'm going to put hydrochloric acid down, HCl, because it gave me that formula, so I'm going to go ahead and write that down. Next, I need to figure out what is magnesium hydroxide. So magnesium hydroxide, magnesium is going to be Mg. Hydroxide is going to be OH. Now I'm writing an ionic compound onto the paper, so I need to make sure that it's electrically neutral. So magnesium, if I look at the periodic table, he's in the second family, so he's going to have a charge of 2+. And then hydroxide is one of our polyatomic ions. He's going to have a charge of -1. So in order to write magnesium hydroxide as electrically neutral, we have to flippity-flop these, the subscripts. So this is actually going to be MgOH with a subscript 2. Okay, so we got to make sure that's electrically neutral. All right, so we've got our reactants onto the paper. Now we need to decide what our products are. So one of our products will always be water, H2O. And then the other product is going to be some sort of salt, right? So we have to figure out, well, what is the salt that forms? So remember this hydrogen and this OH are going to be what forms our water. So anything that is left is going to be how our salt forms. So we've got chlorine and we've got magnesium. Okay. So when I write what's left, I'm always going to write the metal force. So magnesium and chlorine are going to come together to form our salt. But again, I just wrote an ionic compound onto the paper. So we need to check that it's electrically neutral. Magnesium has a 2+. Chlorine is a 1- when it becomes an ion. So again, we've got this flippity-floppity that we need to take care of. So to write magnesium chloride as electrically neutral, it's going to be MgCl2. Okay. So we've got our equation onto the board. Now we just need to decide, is this equation balanced? So I'm just going to take inventory of the molecules I have, the atoms I have, and see what needs to be done here. So hydrogens, be careful here. We've got 1 hydrogen from our acid, and we've got 2 hydrogens from our base, so it's a total of 3. We've got 1 chlorine, 1 magnesium, and we distribute this subscript 2 through, so we've got 2 oxygens. Come to the other side, we've got 2 hydrogens, 2 chlorines, 1 magnesium, and 1 oxygen. Okay. So where do we balance this? Where do we start? I actually don't want to start right here. This hydrogen's kind of a hot mess on this side, and so I don't think I want to start with hydrogen. I might try to start with something a little bit simpler. So I could start with my oxygens, or I could start with my chlorines, and then just kind of pray that the hydrogen shakes out. So let's go ahead and do our chlorines here. So I've got 1 chlorine on the product side. I've got 2 chlorines on, 2 chlorines on the product side, 1 chlorine on the reactant side. So I'm going to put a coefficient of 2 out front here. So that's going to change this to 2. It's also going to affect the hydrogens here. So remember I had 1 originally. Well, now I have 2. So 2 plus 2 is 4. Okay. Next, I'm going to go to my oxygens. So for my oxygens, I've got 2 on the reactant side. I have 1 on the product side. So I'm going to make this a 2. How do I make that a 2? Well, I put a coefficient in front of the water here. So if I have 2 waters that are formed, that means I'll have 2 of the oxygens. But what does that also affect? Yeah, it also affects the hydrogens. So if the coefficient of 2 here, I do coefficient times subscript, and that gives me 4 hydrogens. So now let's just go back and double check that everything looks good. So hydrogen is 4 and 4. Chlorine is 2 and 2. 1 and 1. 2 and 2. So this is my balanced chemical equation for the reaction between magnesium hydroxide and hydrochloric acid. I hope you guys found this helpful.